Now we're gonna do one more figure, and we had a rhombus. Now we're gonna do this thing right here. Kind of looks like a diamond, doesn't it? Yeah, it's a kite, and that's exactly what they call it. Okay, they call it a kite, just like this. Now, what in the world is a kite? It's this thing right here, right? Let me look at the definition of a kite, and that's the. Is it a parallelogram? Yeah, it sure looks like one, doesn't it? Yeah, because this one and this one would be equal to each other. Well, this one looks like it's a parallelogram, but a kite doesn't have to be a parallelogram. All right, this thing could go like way out here like this and down. Kite doesn't have to be a parallelogram. Everybody got that? This one just kind of looks like it, but this could slant a little bit different and still not be a parallelogram. What's true about a kite is this, that you have exactly two pair, let's say how they say it. I always forget exactly the wording. It says a kite is a quadrilateral with exactly, so they didn't say parallelogram, did they? They said a quadrilateral, which basically only means what? If they say it's quadrilateral, what's the only thing really I know about it? It's got four sides, right? So it's a quadrilateral with exactly two pair of consecutive congruent sides, which means it doesn't necessarily, like this one and this one are not consecutive. Consecutive means the ones that are next to each other. So if those two are equal to each other, those are consecutive sides. Make sense? If these two were equal to each other, they would be consecutive sides. Do all four have to be equal to each other to be a kite? No. Right? Only two pair of consecutive sides. Now look, you could have drawn it where this one and this one are equal to each other, and then this one right here and this one right here were equal to each other. All right, you could draw it like that, I guess, but this is one situation where this is a kite. So that's the basic definition of a kite. What we want to do is find the area of the kite. What's cool about this, watch, is it also has to do with the diagonals. So that would be the diagonal. Would be one diagonal, and this, oops, I missed it. I'll drop it down just a little bit. All right, and there would be another diagonal. All right, so it has to do with the diagonals as well. All right. In fact, the equation is so similar to this, it's what? It's exactly this. All right, it's not just close to it, it's exactly the same thing. So again, if I take the two diagonals, multiply them together, take half of it, I have the area of that kite right there. Make any sense? Same exact equation. One is for a rhombus, right, where you have all four sides equal to each other. That's what a rhombus is. This is a kite, where not all four sides are equal, but you have two pair of equal sides. Got it? So these two sides are equal, these two sides are equal. It's a kite. If I draw the diagonals, then those, if I multiply them together, divide by 2, I've got the area of this thing. Let's do an example, and then we'll look at last night's homework. This is confusing your eyes? This thing right here? Why? Looks like a kite? Well, I guess it could be considered a kite. I mean, if these two sides are equal and these two sides are equal, which they are, right? So I guess a kite could be considered a rhombus, right? Well, actually, I should say this. A rhombus, I should say it this way. A rhombus could be considered a kite. Not every kite is a rhombus, but you could say that every rhombus is a kite because it's a four-sided figure with two pair of congruent sides, right? Okay, so yeah, so it is a kite. So it has the same exact formula, doesn't it? Let's look at, let's see what they say. They said that one diagonal of a rhombus is twice as long as the other diagonal. Right, so I would say that one is the one that's twice as long, wouldn't you say? All right, so let's. Can you not be more quiet when you do that? It would really. It's just kind of rude, actually. So watch this distance. I'm not. It's hard to show it inside of here. So this is what they do in the book. They just drop a line down here, drop a line right here, and they say that this is twice as long as this. So, and they also do this. Watch. They go like this, the top of there to the bottom of there. That distance right there is from there to there. Do you follow me? They just say that's a certain distance. What are you going to call it? We don't know what the actual number is. No, we don't want to use that actual number. Use x, right? Okay, that would be the distance from here to here. Or you can say d for diagonal, whatever you want to say. All right, that's x. Now it says, now listen please, it says that the longer diagonal is twice as big as the shorter diagonal. So what am I going to call this? Yeah, 2x. All right, that's kind of how they draw it in the book. And what's the question? it says the area. They tell you the area of this rhombus. They tell you the area this time. Remember we had one like that yesterday where they told you the area? You had to find the base. That's in millimeters and a square millimeters. And what we want to do is find the lengths of the diagonals. So we're basically just solving for x, right? So let's do this. Do we have a formula that talks about diagonals and talks about area of a rhombus? Absolutely. We just finished talking about that. So it's 1/2 d1 d2. So let's see what we have. Let's plug everything in. Do we know the area? Yeah, we do. It's 169. So let's put 169 equals 1/2. Or if you wanted to, you could just put it over 2, couldn't you? Makes the algebra a little bit easier if you do it that way. d1 times d2. What's my d1 and d2?
2x.
It's 2x times what?
X.
Times x, right. And now, what are we trying to do? Trying to solve for x. Absolutely. I'm going to do that. Watch what I'm going to do. I'm going to do a couple things in one step here. I can get rid of this. How do I get rid of the 2? Multiply it by 2. And what is that? Actually, you know what? Don't have to do that. Why did I do that? I don't know why I did that, because it's a lot easier. Watch. What happens here? This is 2x and this is 2. I was like going crazy. Yeah, it's right in front of me. Okay, right in front of me. My dad would say, if it was a snake, it would have bit you. You ever hear that? Okay. So watch. The 2 over 2 actually cancels each other out. So look what you have. You got 169 equals what? X squared. So how do you solve for x then? Square root both sides. What's the square root of 169? It's 13. Now technically it's plus or minus 13. You remember that from algebra? Yeah? But we're not going to use the minus. Why not? Because you can't have a what? You can't have a negative length. So we only pick the positive version of it. Alright? Some people will put plus or minus there, but you're not going to use the negative part of it. You're only going to use the positive. So that's 13. So from here to here is 13. What is it from here all the way across? That's going to be 26. Okay, so your two diagonals are 13 and 26, and that's all you got to do. That's not too hard, is it? Nah, pretty easy. Pretty easy. What's today? Today's Wednesday, isn't it? Okay. No, I'm not going to give you homework today since it's Wednesday. So,
Calm down.
what? I've had Wednesdays where I didn't give you homework.
No.
Yes. All right, that's enough of that, and let's take a look at your homework from last night.